KiCad 9 is now available, and it received some amazing updates that make it much easier to set up electromagnetic field simulations with openEMS. In this simulation, the microcontroller creates a voltage peak on its 5V pin. But because the layout was not perfectly thought through, the signal gets partly blocked by this capacitor. But as there is a second trace routed under the microcontroller, noise can escape and spread over the whole PCB area. Alright, let's now start with the setup process. I will keep this video short and only show you how the workflow improved in KiCad 9. The remaining steps are the same as I showed in my other simulation videos. First, open a layout file with KiCad 9. The link to the specific layout is in the description. Mark all the components that you want to include in the simulation. I specifically want to include the capacitors on the 5V rail. Now go to the step export and export the board, the traces and the capacitors. Now we have to export the component pads. We will later use them to connect the capacitors to the PCB. We want to export the top pad separately. For this, make only the top layer visible. Mark all the visible items with Ctrl+A. And then press delete on the keyboard. Go to the step export again and export the pads. This now exported the pads of the bottom side. Now also export the pads of the top side by going one step back in the history with Ctrl+Z. Then make only the bottom layer visible. Mark all visible items with Ctrl+A, hit delete and go to the export menu again. We are now done in KiCad. Open FreeCAD and create a new project. Import the step files. Now move the top pads up by 0.2 mm and the bottom pads down by 0.2 mm. All the pads now have a slight overlay with the capacitors, and openEMS can later use them as a connection. That's it. This is basically the new workflow with KiCad 9. The remaining steps are almost the same as in my other YouTube videos. If you are new to this channel, please proceed to the capacitor simulation video. It will show you all the needed steps to create the capacitor simulation. Thank you for watching and see you in the next video.